Alright. Bismillahirrahmanirrahim. Assalamualaikum. To Sir and my friends. My name is Abdul Wafi and this is my friend Badrul Zaman and Anis Sufika. So basically, we want to explain about Select 4, Telecommunication Electronic, which is the title is Single Tune Amplitude Design. Alright, so we can go through the procedure. Alright, in the procedure, we has 4 tasks, and the first task, which is we must construct this circuit using follow this picture given, and we in Multisim software, and we get the we fill down the table in the table, and you can show in table we get the gain is 7.100 dB, and the frequency in recorded, which is 4.339 kilohertz. And the calculation, we must use the formula, which is 1 over 2 square root L C. So after we calculate calculator, we get the 4.414 kHz. Alright, and go through to task 2. Okay, task 2, the same previous task. We must, after we construct, we get the we fill down the result. But in this task, we must change the value of voltage. You can see voltage from 6 and increase until 18. So after we increase, we get the answer, get the data, and we pull down in table, and we do the graph and show the graph. Okay, for graph 1, which is the part C for X is VCC and y-axis is gain, and you can look at the graph increase. And the second graph, which is frequency VS to gain, and you look the graph, which is the straight line. So we can conclude for this task, for VCC value is increased when we can observe the gain is increased, but the frequency FR does not change. The value remains constant. That's all from me, and we will pass the Badrul Zaman. Thanks.
Okay, thank you. Okay, for this task, it basically same as the previous task. So the only value that we change on this task is the capacitor value. So the VCC remain unchanged at 12 volt, and the frequency calculated is we'll calculate from formula 1 over 2 pi times square root LC. So as you can see from the table, the first graph we had is the capacitor versus gain. So from the value from the table, the graph is sometime decrease and sometime is it increasing. So the graph is bit unstable, but it goes like that. The maximum from that graph is at the 17. When the capacitor value is 17, the maximum gain we can achieve from that graph. Okay, for the second graph, this one is the resonant frequency versus the capacitor. So this one is, as the value capacitor is decreasing, the graph, the frequency of resonance is increased also. So what I can conclude from this task is whenever the value of the capacitor is increased, we can see that the frequency of resonance value is decreased. So it actually the gain has the fluctuation in the values that can also we can see from the graph. So the next task I pass to Anis.
Okay, so task 4, the circuit is remain the same, but we change the value of inductor. So here we can see in the table the value of inductor change, as we can see the gain value and frequency value also change. And for the graph, we can see that inductor versus gain, the graph is unstable. And for the second graph, frequency over L, as we can see here, as the minimum value of L, which is we can take at 100, the frequency value become bigger. So for this part, we can conclude that when the inductor value increase, we can say that the value of frequency decreasing, and the gain has a fluctuation value that can also be seen in graph. Okay, that's all from us. Thank you.